Good morning, guys. It's Peter McMahon giving you guys a first lesson of Math 31, or this Math 31 AP, guys. This will be the same lesson for either course right now. And the topic is called the formal definition of a derivative, okay? So, guys, for this part, guys, I'm assuming that you guys have a kind of a basic understanding of the limits unit that we covered already here. And I'm going to go through a bit of review on limits and then kind of start getting into using limits to figure out slopes of tangents, and then kind of showing you what we call Formula 1 and Formula 2, which are our two formulas that we use for the kind of the formal definition of a derivative. Sometimes we call those ones first principles of a derivative as well. Okay. All right. Example one here, guys. This is really a review from like grade 10 math. And it's quick. It says write the equation of a line that passes through 0.54 and has a slope of negative 1/2. So when we're doing this guy, I'm going to show this question two ways. Here's probably the most common way, guys, that you guys would have learned is y equals mx plus b. I'm going to show you this way, and I'm going to show you which I think is the more convenient way for this course over here. So in this one, we're going to call this point x, y, and our slope equals negative 1/2 is our m value. So we have 4 equals negative 1/2 times 5 plus b. That means 4 equals negative 5 over 2 plus b. And so when we add 5 over 2 to both sides, that means we get 13 over 2 is our b value. So we get y equals negative 1/2 x plus 13 over 2. Okay, so this is one way we can write the equation of a line, and this is in slope-intercept form. Now, another form of a line that we didn't use as much in Math 10C, but I think it's going to be a lot more convenient in this course. So you're going to be doing this quite a bit in this course, where we're going to be giving you a point, and you're going to calculate a slope, and you need to figure out the equation of that guy. Well, the point slope form of a linear function is y minus y1 equals m x minus x1. Okay, so this is the point slope form over here. So if we have a point over here, we're going to call this x1, y1 here. Our equation is simply going to be y minus 4 equals m, which is negative 1/2, times x minus 5, and we're done. Okay, so just this is kind of the way that I'm going to recommend that we kind of just calculate equations of lines for the most part in this course over here, guys. It's simple. It's definitely a good way to do it. And if I wanted to convert it into slope-intercept form, I would just distribute the negative 1/2 through the brackets and set and solve for y on the left-hand side over here, and I would come back to the same equation that we calculated in slope-intercept form. All right, example number one. I got a few limits we got to calculate over here. Now, the idea for calculating limits like this is you want to be able to substitute your value for x. So this is x approaching 4. You want to be able to substitute 4 into your equation over here. Now, the problem is we can't because we have an x minus 4 in the bottom of the fraction. So by plugging in x equals 4, it's going to give us a dividing by 0, which is undefined. Okay, so we can't plug in 4 yet. But what we're going to do here is the goal for a lot of these questions is going to be to kind of be able to simplify in some way, cancel some terms out, some factors out, and then make your substitution afterwards. X squared minus 2x minus 8 factors to x minus 4, x plus 2 over x minus 4. The x minus 4 terms cancel out. Okay, and now we can just plug in, since we've canceled out our term our factor in the bottom of the fraction, which is our non-permissible value, we can now plug in 4 into the top of the fraction, and we get 4 plus 2 equals 6. So this answer is 6. Okay. For this one over here, we have the limit as x approaches 9 of square root of x minus 3 over x minus 9. Same problem. We can't plug in an x equals 9 because we're going to have a 0 in the bottom of our fraction here. The technique that we learned is we want to be able to rationalize the numerator for a question like this. And to do that, we need to multiply by the conjugate. Okay. Now, what rationalizing the numerator is going to do here, we're going to expand this out. Root x times root x is, still the limit as x approaches 9, is x plus 3 root x minus 3 root x. Those two terms cancel out, minus 9. Now this is good because we have an x minus 9 factor in the bottom. Then we have root x plus 3, cancels. We have a 1 in the top, okay? So this works because we've gotten rid of the root x minus 9 in the bottom of the fraction, which was our non-permissible value. And now we can plug in the x equals 9 into this expression here. And we get a value of 1 over 6. Okay? All right, guys, I'm going to take a quick pause over here and start you in the next video here. So this is kind of a quick review on limits and writing equations of lines.